Imagine you could choose your future child's traits from a catalog: eye color, height, intelligence, even immunity to disease. This isn't science fiction anymore. It's the new frontier of human genetics, made possible by genetic engineering. The idea of designer babies sparks both hope and fear: the hope of eradicating genetic diseases and the fear of deepening inequality or unforeseen consequences. The choices we make about this technology will shape humanity's future. So, let's dive into the science, the ethics, and the reality of designing our descendants. Understanding is the first step. Let's see what's possible, what's not, and what's at stake. The term designer baby might sound like something out of a science fiction movie, but it's a concept that's rapidly becoming a reality. At its core, a designer baby is a child whose DNA has been intentionally selected. This selection process aims to influence specific traits, or in some cases the DNA is directly edited to include or exclude specific traits, opening up possibilities and raising complex ethical questions. This is a significant leap beyond simply choosing a healthy lifestyle during pregnancy. It goes right to the source, editing the embryo's genetic code itself, potentially altering the course of development. The potential implications are vast, and the first real-world case, which sparked intense debate, happened in 2018. This involved twin girls in China who were edited using CRISPR technology in an attempt to make them resistant to HIV. This event ignited a global controversy, raising serious concerns about the ethical boundaries of genetic engineering. It's important to understand that there's a key difference between selecting embryos to avoid disease. This selection process often involves using pre-implantation genetic diagnosis, or PGD, to screen embryos for genetic disorders. This is different from actually editing genes, a process known as germline editing. Germline editing is particularly significant because it passes changes to future generations, permanently altering the human gene pool. Selecting against disease is often viewed as a form of preventative medicine, a way to ensure healthier lives. However, editing for traits like intelligence or other cognitive abilities raises more complex questions. Similarly, editing for appearance is much more controversial, as it ventures into the realm of enhancement rather than therapy. The line between therapy and enhancement is often blurry and subjective, making it difficult to define clear boundaries. And that's precisely where the ethical debate lies, in determining what constitutes acceptable use of this powerful technology. As our tools become increasingly sophisticated, society must grapple with the difficult question of where to draw that line, or perhaps even more fundamentally whether to draw it at all, considering the potential benefits and risks. Ultimately, the future of designer babies is as much about our shared values and societal priorities as it is about the advancements in science that make it possible. It's a conversation we all need to be a part of. The revolutionary tool making all of this possible, the ability to precisely alter the very building blocks of life, is CRISPR. It's a groundbreaking technology that has transformed genetic engineering. Think of it as a kind of molecular scissors, incredibly precise and guided by a GPS system. This GPS allows it to navigate the complex landscape of our DNA. Its primary function is to target and edit specific genes with remarkable accuracy. It's like having a find and replace function for your genome. Scientists are now able to use this technology to disable faulty genes, the ones responsible for causing diseases and disorders. They can even go a step further and replace these problematic genes with healthy ones, offering the potential to cure genetic illnesses. But it's crucial to remember that the process isn't perfect. We are still in the early stages of understanding its full potential and limitations. As with any new technology, mistakes can happen during the editing process. These errors can have unintended consequences, and we must acknowledge that there are still unknown long-term effects associated with altering our genes in this way. Beyond CRISPR, pre-implantation genetic diagnosis, or PGD, offers another avenue. It lets parents select embryos that are free of certain diseases before implantation. Furthermore, polygenic risk scoring is a method used to estimate the likelihood of inheriting certain traits. These traits can range from physical characteristics like height to the predisposition for developing certain diseases. It's important to remember that polygenic scores are probabilities, not guarantees of a particular outcome. These scores are based on limited data and our current understanding of the complex interplay of genes. While these technologies represent significant advancements, they are still relatively blunt instruments in the grand scheme of things. We're only beginning to scratch the surface and understand the full impact these technologies will have on individuals and society. Editing one gene can have ripple effects elsewhere in the body, impacting other genes and biological systems in ways we don't fully comprehend. The field of genetics is advancing at an incredibly rapid pace with new discoveries and technologies emerging all the time. But despite this progress, we're still far from offering total control over a child's future or eliminating all uncertainties. We're learning as we go, constantly refining our understanding and improving these technologies through ongoing research. And with such powerful tools at our disposal, the stakes couldn't be higher as we navigate the ethical and societal implications. The promise of these technologies is undeniably huge, offering the potential to eradicate diseases and improve human health. But we must proceed with caution, because so are the risks associated with altering the very fabric of life. The greatest promise of genetic engineering is eliminating inherited diseases like Huntington's, cystic fibrosis, and sickle cell anemia. For families affected by these conditions, gene editing could end generations of suffering. In the future, we might even reduce risks for complex diseases like heart disease or Alzheimer's by editing multiple genes. Imagine a world where people are born with built-in resistance to major illnesses, even some infectious diseases. This could transform public health, reduce healthcare costs, and give everyone a better quality of life. Supporters argue that if we can safely prevent suffering, we have a moral obligation to do so. Ultimately, it's about giving every child the best possible chance at a healthy life. But the ethical concerns are enormous. If only the wealthy can afford genetic enhancements, we risk creating a society divided by biology, a genetic aristocracy. Editing the human genome could have unintended permanent consequences for future generations. We don't fully understand the long-term effects, and mistakes could be passed down forever. There's also the risk of reducing human diversity and devaluing people who don't fit the new ideal. The pressure to create the best child could become overwhelming for parents. Where do we draw the line between therapy and enhancement? Once we start, it may be impossible to stop. We risk turning children into products rather than unique individuals to be loved for who they are. The ethical minefield is as complex as the science itself. Globally, most countries ban heritable genetic modification in humans, reflecting concerns about safety and ethics. In the US, regulations effectively prevent creating designer babies, though research continues in labs. These rules aren't set in stone. Future political or scientific shifts could change them. Meanwhile, research on gene editing and embryo selection is advancing rapidly. International bodies are working to develop ethical guidelines, with many calling for a moratorium on clinical germline editing. The consensus, if we ever proceed, it should be for serious medical reasons, under strict oversight, and with broad public agreement. The debate is no longer about whether we can do this, but how, and under what circumstances, we should. The rules of this new genetic era are still being written. We stand at a crossroads, a pivotal moment in human history. The choices we make today regarding genetic engineering will reverberate through generations to come. Genetic engineering holds the incredible potential to free us from the shackles of disease and alleviate immense suffering. Imagine a world without genetic predispositions to cancer, Alzheimer's, or countless other debilitating conditions. But this powerful technology also carries profound risks. It could inadvertently deepen existing inequalities, creating a society where genetic advantages are accessible only to the privileged few. Furthermore, it could erode the very essence of what makes us human, leading to unforeseen and potentially irreversible consequences. The technology's immense promise is inextricably linked to its inherent risks, social, medical, and philosophical. These are not merely scientific hurdles, but complex ethical dilemmas that demand careful consideration. Are we truly wise enough as a society to wield this extraordinary power responsibly and ethically? Can we ensure that it benefits all of humanity rather than exacerbating existing disparities? The decisions we make now will shape not just the first generation of designer babies, but the very fabric of our society. It will determine the future of humanity itself, influencing our evolution and shaping the kind of world we leave behind for generations to come. This isn't just a scientific question confined to laboratories, it's a profound moral one that touches upon the core values of our society. And therefore, it belongs to all of us, regardless of our background or expertise. We all have a stake in this future. Would you choose to design your own child to prevent the onset of a devastating disease, knowing you could spare them a lifetime of suffering? What about going further, to enhance their intelligence, physical abilities, or even their appearance? Where do we draw the line? Where would you, personally, draw the line? What principles would guide your decisions in this uncharted territory? There are no easy answers to these complex questions, and simplistic solutions are unlikely to suffice. But asking the difficult questions, engaging in open and honest dialogue, is absolutely essential if we hope to navigate this new frontier responsibly. The future of what it truly means to be human, with all its complexities and imperfections, is now, quite literally, in our hands. So let's proceed with caution, carefully considering both the remarkable potential of the science and the enduring importance of our shared human values together. Don't forget to subscribe, set a comment, and ring the bell.